Okay, so let's take a look at 10.1, which is describing patterns. So our main things we're trying to do is describe patterns using words, tables, or diagrams, and to also use repeating decimal numbers as patterns as well. So for this first one over here, it says to describe the pattern. So if I take my highlighter, let's imagine these two original squares. I could imagine that they are here the whole time. And so each time, if I was to take a look at what's happening, it's growing two more on top, two more on top, two more on top. So to describe it, I would say it starts with two squares and add two each time on top. Somebody else might see it differently. So for somebody else, they might view this as the original two squares, and then maybe each time it's actually staying on the top. So then for them, they might view it as adding two on the bottom each time. So every single time we just elevate it and add two on the bottom. That would work. It would still give you the same pattern. And so however you view it is okay. So next one, how many squares will be in figure 5? Explain our reasoning. So let's try and use this table over here. So I'm going to go figure and the number of squares. So I have figure 1, 2, 3, 4, 5. And then for the squares, this first one has 2 squares. This next one has 4 squares. And then 6 squares, 8 squares, 10 squares. So how many squares will be in figure 5? 10 squares. So 2 more than in figure 4. Or something else you might notice is each time you actually just multiply it by 2. So if I take any figure number and multiply it by 2, I'll end up at the number of squares. So another way, squares are always twice the figure number. Okay, let's take a look at the next one. So Jameson makes an increasing pattern with squares. He records the number of squares in each figure in a T-table below. So this time there's no picture. We're going to have to think a little bit more abstractly. So first of all, what's a pattern? So if I take a look here, I can see each time I'm adding 8. So I would say the pattern starts with 11 and add 8 each time. So now it says, can you figure out the rule of how to get from the figure number to the number of squares? So if I grab a different color, now I'm actually trying to find this conversion. So usually it is actually tied to how much it increases. So I know each time it increased by 8. So if I think about it, if I had to guess what 5 would be, I would need another group of 8. So that must mean I'm actually multiplying by 8. So each time I'm multiplying by 8. This isn't quite correct yet because 1 times 8 doesn't get me 11, 2 times 8 doesn't get me to 19, but I can do another operation. So 1 times 8 gets me to 8, and then I just need to add 3 more to get to 11. 2 times 8 is 16, add 3 more to get to 19. 3 times 8 is 24, add 3 more to get to 27. 4 times 8 is 32, add 3 more to get to 35. So the rule of how to get from the figure number to the number of squares, so multiply by 8 and add 3. Or I could say it is 8f plus 3. So 8 times a figure number plus 3. So if I said figure number is f, and then I'm going to say the number of squares is 8f plus 3. How many squares are in figure number 40? So let's plug it in. 8 times 40 plus 3. So 8 times 40 is 320 plus 3, altogether 323. So there would be 323 squares in figure 4. If we take a look at repeating numbers, so 3, 6, 9, they're adding 3 each time, so 12, 15, 18. over here, there's a pattern. So 1 divided by 9 is 0.111, so on. 2 out of 9 is 0.2222. 3 out of 9 is 0.3333. So what pattern do I see? Numerator divided by 9 will be repeated decimal, 0 point, followed by a repeating numerator. So if I followed that same pattern, 6 out of 9 should be 0.666, so on and so on, or I might write this as 0.6 with a bar on top. 0.7 with a bar on top as a fraction would be 7 out of 9. Alright, hopefully that helped out in terms of some basic patterns. If you have any questions, just reach out to your teacher. Good luck!